What do you have there, Max?
It's a U-matic video tape.
It's ringing like a bell. Hello. Let's cover a little bit about the Umatic video cassette format, some of its strengths and weaknesses, and the machines that we use today. Now, this format was originally announced by Sony in 1969 and was released in 1971, but it wasn't a Sony-only format. In fact, lots of manufacturers got together to agree a standard on this, and you will see occasional machines with other brands such as JVC. Now, initially it was released in just a large tape size, but later on, for portable use, a smaller tape size came along. Not that it's particularly small, because both tapes use a fairly wide tape. Most videocassette formats that we're used to, at least for domestic use, were half-inch tape width. Now, Umatic uses a 3/4 inch tape, so it's 3/4 inch across. And so the format was often known as 3/4 or 3/4 inch. But that was actually a bit vague because there were one or two other formats that used 3/4 inch tape. Now, these particular tapes you see here are one of the later variants, and we'll go into that shortly. If you want to prevent an accidental recording on one of these tapes, there's a red tab fitted here, and whoops, it's a bit clunky. You pull it off, try not to lose it, and that prevents recording on this tape until you refit it. So that's obviously not as good as a switch, such as you get on other formats, such as Betacam SP. Now, there's a certain amount of confusion because the standards they used for these varied between PAL and NTSC countries. So in PAL countries, we had 3 variations on these tapes. There was the original format, which later became known as low band, which just uses an oxide tape, and has around about 250 lines of resolution. That's not to say 250 lines of vertical lines that you get from one side to the other. It's 250 lines per vertical height. So it's about 300 and something across the screen, 330 I think. So that resolution is fairly limited. It's about the same as domestic Betamax. It was okay for industrial use and sort of commercial things, such as I've seen quite a lot of these tapes were used for example, car showrooms would have tapes sent to them showing the latest models, and it's great for that sort of thing. When you consider we're going back to the early 70s, the performance was more than adequate for that. And it started to get used by TV studios as well, because they wanted to get away from film, and they could do electronic news gathering on Umatic. It wasn't really good enough for broadcasting whole programs, but it could be used for occasional use, and it was also used a lot by the advertising industry. So very often adverts would be supplied to TV stations on the Umatic format, even though the resolution was a little bit limited. Standards generally were a lot lower in the early 1970s. Now, that was a successful format, but there was clearly a requirement for a higher resolution version. So, at least for the PAL markets and maybe CCAM. CCAM's a little bit complicated and we'll not go there. Let's look at PAL. Sony introduced a high band version of the format. It used the same kind of tapes. They didn't change anything there. It altered some of the frequencies in such a way that it was possible to get around about 330 lines of resolution, which was a very useful improvement. Now, if you tried to play one of those high band recordings on a standard machine, it would play with more or less a black and white picture. That's what you'd see as a black and white picture. There would be some tiny imperfections in that. So that's not ideal, but it was possible, since there were no fundamental changes to the tape, it was possible to retrofit a high band playback capability on some low band machines. So, yeah, that was quite useful. But more was needed, and so they introduced the SP formulation. So these tapes all have these blue markings and SP in the model number. So these are actually chrome dioxide tapes, and they produce the same resolution as high band, but gave a better picture again, and that was released both in NTSC and PAL countries. So in PAL land, high band means something slightly different to SP. Now in NTSC countries, it may be they get a little bit sloppy with the terminology and will refer to SP as high band, but it's not exactly the same thing. Now that gave a much better quality result, such that compared to the later Betacam SP format, certainly if you were looking at an original recording on a Umatic SP and a Betacam SP, you couldn't necessarily see the difference that much. The performance was not bad. Betacam SP has a resolution of around about 360 lines compared to this 340, so 330. So a good effort. Now, I would argue that Betacam SP has better noise and better colour performance. I think most people would say that. But in some shots, Umatic SP was very useful. Now, one of the tapes I've been showing you here is actually something a little bit different, because as well as recording normal video with 2-channel audio, so stereo if you like, audio on Umatic videotapes, they could also have this format where the video was repurposed to a digital data stream, and it's digital here, and this was used for PCM digital audio in the early days of CD manufacture. So machines were PCM model number PCM 1600, 1610, 1630, the decoders, and they had some special recorder players to go with them, such as DMR 4000 as well. So that was another use for the Umatic format. Now let's look at how you'd connect up your Umatic video recorder. Many Umatic video recorders only have composite video outputs, and some offer a dub connector. Let's look at the composite video situation first. You would typically want to connect a Umatic video recorder if you're going to digitize the material today, or back in the day if you were going to dub and edit and do such things. You would want to connect that to another machine or capture device, and you'd want to connect it typically via a digital time-base corrector if you can. So here's a sort of prosumer model. It's the ACE digital converter from GTH Electronics. Actually, they're quite a capable unit, this. It may look a bit sort of homegrown, but they are useful. And you would connect your Umatic video recorder to the composite video input. It'd be lovely if we could use the S video input, but as we've mentioned, you only get composite and sometimes a dub connector. And the dub connector is incompatible with S video. The signals are different. Even though the functionality is very similar, there's no easy way to convert from dub to S video, so we can't use it. The reason for that is that the chrominance subcarrier for PAL, for example, is 4.43 megahertz. On dub, it's down converted to, what is it? On low band recordings, it's 0.686 megahertz, and on high band recordings, it's 0.984 megahertz. So there's no easy way to convert that back to the 4.43 megahertz subcarrier required to work with an S-video connector. Now you might say, well, that's just a weakness of using this sort of prosumer time-based corrector. Bet it would be better if you had a professional one. So here we have the G2 MSTC Ultima professional grade time-based corrector. You have a lot more features on this you wouldn't get on that one. A lot more connectors, including, for example, YUV inputs, which you might connect, for example, to a Betacam machine or M2 or some other professional machine, but no dub connectors. So you're in the same position. All you can do is connect to the composite video. And these are both perfectly capable units. They will have a digital comb filter built in, so they can do a great deal of masking of the effect of using composite video. And in a first generation composite video connection to one of these, you'd be hard pushed to tell the difference between that and a dub or S-video connector. So they help a lot, but it's not the whole solution. So ideally, you'd want to connect to your digital time-based corrector using the proper dub connection cables, which is a multi-way cable, rather hard to find, to something which does have a dub input and can handle the Luma and Chroma separately. And such time-based correctors do exist, but they're rather hard to find. I have two of the model DPS375, and these do the job brilliantly. Now, the way I suspect they work, because you also have to connect the composite video as well as dub, is I think it takes the luminance via the dub cable and the chrominance via the composite video and strips the chrominance out. And that's okay because there's no loss of bandwidth in composite video for the chroma. There only is loss of bandwidth for the Luma connection. So that, I believe, is the way these time-based correctors work. And there's another model from another manufacturer. It's the 4A FA310P, and I suspect that that does it in the same way. So if you can get hold of one of those time-based correctors, that's the ideal way then to connect to a Umatic video recorder. You can then take an output from that time-based corrector as S-video or YUV and connect that to your modern digitizing equipment and get really excellent results. Okay, so that's connection sorted. But actually there are some weaknesses in Umatic which extend beyond just the connection problems and composite video problems. And that is an effect called ringing. And this is a problem with filter design. So it's clear that when they designed the format, they had a bit of a compromise in how they were designing the filters used in the video processing. The exact detail for that I don't know, and possibly nobody knows outside Sony. But the effect was that you would often see, when you had a sharp vertical transition, you would see lines to the right and even, to a lesser extent, to the left of that vertical transition. And you can see this effect in lots of videos that have appeared on broadcast and are still available now. And I'll give you some examples here of music videos and other broadcasted programs where you can see Umatic ringing. Now, every time I see a program on TV where I see that distinctive ringing effect, I shout to my poor wife, "Oh look, Jane, it's more ringing on Umatic. Look, I can see it's Umatic." And my wife's not very interested.
Yes, it's Umatic.
It's worth taking a look at the tapes themselves because they're quite an unusual design. Let's start by looking at the smaller tape, because with this window right across it we can see it a little bit more. What's really unusual compared to normal video cassettes that we're all familiar with, or indeed audio cassettes, is that the supply spool is on the right. So the tape goes from here to here, which is of course the opposite way around to most, which is why here you have a window on this side. And those formats where you only get one window, such as some mini DV tapes and some beta tapes, normally it's the left window which is visible because that's the amount of tape remaining on the cassette. The other really strange thing about it, you can actually see it from the arrows on here, is that the tapes, their spools run in opposite directions to each other. So when playing, that is the operation. So what's going on here is the tape is actually wound the other way round on itself on the supply spool. They probably did this. My guess is that they're trying to reduce an effect called print through, which is where if tape is allowed to sit in a pack for a long time, then the signal from one rotation of the tape can start to imprint on the next. And typically this will be heard on audio tapes, where you'll hear a very faint echo or pre-echo. So you'll hear a piece of music start very faintly before the music actually does start, and what's happened there is you get print through. and I've heard that on audio cassettes. Now, it may be that by having the tape sometimes wound one way and sometimes wound the other, that there's potentially a little less inclination for print through to happen, or it might be because they're thinking that the tape itself might benefit from being turned both ways. Maybe that reduces tape curl. But no other video cassette format ever did that. There's something else that's unusual about these tapes, and it doesn't apply on this smaller tape, but does apply on the bigger ones. Looking at this, you can see there's a flange at the bottom of the spool, but there isn't one on the top of this large tape. There is on these small ones. And what that's about is, as the tape vacates the supply spool and builds up on the take-up spool, it starts to use the same space as was used on the supply spool. So it allows the tape to contain a lot more running time, it allows a cassette to contain a lot more tape for a given size. The only other format that I'm aware of that used that technique for videotape was CVC. But you do see it in audio cassettes and DAT audio tapes where the tapes are held without flanges on the spools so that you can release space inside the cassette. You can see the space savings effect best with this tape, I think. As I rotate the take-up spool here, you can see the supply spool feeding out, but the top flange here is over the top of the tape from the supply spool. So that saves a lot of space inside the cassette. Now, we've discussed some of the problems we can have with Umatic, either as a result of its design flaws with the ringing on the low band format in particular, and with connection problems and hence dot crawl caused by composite connections and multiple composite copies. But I found I can sometimes improve them, and it's not by using my really expensive time-based corrector, but it's coming back to this prosumer one, the ACE unit by GTH Electronics. It has a sharpness control, and the way this works is quite subtle. In fact, I've spoken to the designer of this, and even he doesn't know entirely how it works. But if I was to back off the sharpness, so that's the standard setting there. If I'm playing a Umatic tape where I'm seeing a lot of crisscross patterning or ringing, if I back off the sharpness to about there, you lose some resolution. But magically, very often, not always, very often the ringing and dot crawl patterns can disappear. Completely disappear. And here's the really strange thing. If I then turn the sharpness even further down, the ringing and dot crawl patterns come back again, even though the resolution is lower. There's a sweet spot somewhere around about there, which can get rid of those artifacts at the cost of some resolution. In the case of some tapes, that's a price worth paying. The overall result is more watchable on a reduced resolution rather than the maximum possible amount of resolution, but with all the dot crawl and ringing. And by the way, I've tried going the other way just on the off chance that there's a sweet spot on the other side, and there isn't. So this is something to do with the way that filtering works and the poles you get in filter design. I used to know all about that sort of thing, but it's been some years since I was involved in that. But this can do a certain magic there, which the other time-based correctors don't do. Try to demonstrate it here. This is mostly the crisscross patterning you tend to get with composite video connections rather than the ringing, but you get a similar effect. So we've started in the center position, I back it off to the left, get it to the sweet spot, and the noise seems to largely disappear. But then rather counterintuitively, if you turn the sharpness further down, the noise comes back again. If I, however, take it all the way back up and increase the sharpness, it just gets worse and worse. So there's no other sweet spot on the other side. Fortunately, I'd say the majority of the tapes I get through, they are fairly good quality. They go through my DPS375 time-based corrector, and I don't see ringing and dot call patterns too often, fortunately. Especially with PAL, I tend to see it more often with NTSC tapes actually. A quick mention about resolution. You'll remember we said earlier that the luminance resolution of Umatic in its early version was around about 250 lines, similar to Betamax, whereas VHS is around about 240, and the high band and SP version of Umatic was around about 330. Now, these were all wiped away by Betacam SP, which was a hugely successful format, and I've covered this in the past, with about 360 lines of resolution, but much better chrominance performance and noise performance. One of the big weaknesses, I think, of Umatic was that colour performance could be less than ideal. There's comments about it being particularly poor with reds. Certain colours could cause interference on Umatic. So it did fail a bit in that respect, and though you could make a Umatic to Umatic copy and use it for editing, it wasn't great. Better than if you'd done it with something like VHS, of course, but still not really brilliant. Now, there's a lot more to resolution than just the luminance resolution. So we can look at how many lines you can get from a videotape and think, oh, that's brilliant. Super VHS is 420. There is an extended definition beta format, 500 lines resolution, which is like DVD quality. You could think then that they're broadcast quality. That's wrong, because the chrominance performance, for example, looking at Super VHS, the colour performance of Super VHS is exactly the same as domestic VHS. Now, if you've ever tried to watch something like snooker, where you have a green table and coloured balls on it, on VHS or Super VHS, you'll quickly realise that the colour performance on VHS is absolutely shocking. So you get a kind of a coloured blob somewhere near where the balls are supposed to be on the table. Awful performance. So that's why in broadcast they would use something like Betacam SP, which didn't necessarily have the luminance performance of say Super VHS, but overall as a package for editing performance it was vastly better than Super VHS. Something else I think we should mention while we're looking at the Umatic format, these tapes are Sony, and they're amongst the best actually. But it's worth mentioning some other brands that can be a little bit more troublesome. Ampex in particular. Their tapes have a particular formulation which is not stable over time, and they can suffer from something called sticky shed. There's two parts to that. Sticky means that they stick in the machine, and typically you hear squealing or the machine will shut down. And shedding, which means that the material, the recording material, sheds off the tape. It's not stuck properly to the binder or to the backing, and it will come off and clog the heads repeatedly. And I have a baking process, well documented. In fact, I think Ampex invented the baking process, which you put it into an oven at 50 degrees Celsius for some hours or even days, and it can stabilize the tape enough to make it playable. But they're not the only tapes that can suffer. I've found that 3M and Scotch branded tapes on Umatic in particular suffer from something called poor magnetic retentivity, which is that they tend to self-erase. So you can have a problem with very low RF reading. There's a meter on some of the machines that actually gives you an RF level, and that will be extremely low. It looks like, oh, what's wrong with my machine, or the head's worn out or clogged or something, but it's actually the tape itself has lost its magnetic information, and there's nothing that can be done really to improve that when it happens. Despite all these criticisms, I actually like the Umatic format. I find it's generally reliable and robust, and when I get Umatic tapes in, I'm normally a happy person, so long as they're not Ampex. So I hope you've learned a little bit about the Umatic format. Do leave your comments if you've worked on it before, and what your experiences are with Umatic. Bye for now.